In machine learning, we build our models using data from the past, but we have to make predictions in the future. And these two are not the same world. So the question that every ML system has to answer is this: will your model survive when it is going to cross this line? And for that exact same reason, train test script is designed. Most of us learn train test script as a data management decision. You have got a data set, you keep 80% for your training and 20% for testing. You train a machine learning model using your training data set, which is 80%, and you run it on test data set, and your metrics looks good. This is what the evaluation step is. And this is exactly where all the problems start. If the test data set is only to evaluate your model, then why does it matter whether you scaled your data before or after this is split? Another question is, why does a model that scores perfectly on a test data set sometimes fail the weeks after deployment? So the data management driven mental model is incomplete. And that is the gap what we are here to close today. So now let's talk about the mental model that actually matters. Your test and train are not just two half of the data set. They actually represent two very different worlds. Everything that your model is allowed to see lives on this side. Here you will have your training data. You will have your pre-processing. You will also have your scaling. Then you will have your feature selection, as well as all of your model hyperparameter, etc. Now coming to the right side, everything here is still empty. Why? Because your test set is not a grading system. It is the simulation of the future or the production world. The entire value of your test dataset comes from just one guarantee, that it has stayed completely invisible to any decisions that are being made on the left side. The moment anything from the right side crosses this line or it influences any of these steps, the simulation is compromised and it will not fail loudly. It will fail after 6 weeks of the deployment. And the line which splits your training world and your test world is what we call information boundary. Anything on the right side should never influence anything on the left side. Now let's talk about three real world scenarios where this boundary gets crossed unknowingly. The first one is pre-processing. Let's take an example here. So you have defined a scalar and call your fit transform on the entire data set. And then you split your data into test and train. Now you may wonder what went wrong here. So Your scaler already knows the test set's distribution via mean and standard deviation. So test sets mean and standard deviation are already influencing how the values are scaled in your training data set as well. So the information boundary here is already broken even before your training starts. So now how do we fix this? What you need to do is basically split your data before you do your fit transform. So you have already split your data into test and train, and now you are going to fit transform only on your training data set and use those learned training distributions on your test data. Why does that matter? Because in production, you will never be able to get distribution of your future data points. And if you go with the old approach, your model will fail silently. Second one is your time. Suppose you are working on a transaction data set and you have decided to do test and split randomly. Uh, so maybe let's suppose you have Jan, Feb, March, April, May, and June. So while you are doing the random test and split, let's say you have your January in your training data, March in your training data, April in your training data, and June in your training data. So all these are your train, 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 and train. And the remaining one are your test data set and test data set. So the challenge in this approach is that your model has already seen the future. So what do you mean by that? Is basically when you are going to train the model based on the March transactions and you are going to test it on Feb transactions, it has already seen the future while training itself. So what is the solution here? Whenever you are dealing with your temporal data, what you need to do is basically you need to draw a boundary which respect the time. So anything left side of this temporal boundary will become your training data set, and anything on the right side of it will become your test data set. So in this example, your January to April will become training data and May to June will become your test data. Now coming to your third one, this is the most dangerous. When some of your feature are influenced by your outcome variable itself. Let's take an example. So let's say you are predicting for transaction fraud and one of your feature is named is transaction under review. Now usually transaction goes under review if those are suspected to be fraudulent or they are already confirmed as fraudulent. And this flag typically populates once you have completed your transaction. Now you will never be able to get any reliable value of this flag in the production. Why? Because by that time the transaction has not completed itself. And do you know that your model loves such sort of features? Because then model need not to work harder. It will just look at your answers. That means the features which are dependent on your outcome, and then it will simply predict your outcome. And even when you are going to plot your feature importance, these kind of features are going to top your list. So in the real world, the way it's going to look like is your model evaluation based on test data set will be telling you somewhere around 99% of accuracy. But 4 weeks down the line in production, that accuracy will drop down to 61%. And this will fail silently. This will not raise any error for the model run. And the debug for this also going to become very costly. So this is the cost of broken boundary that you pay, and it fails silently. So the question now is, how do you protect your information boundary? So consider your test data set as a sealed envelope, and it should be opened only once during your entire ML lifecycle. That is during your final evaluation. So never use your training data set for debugging what is going wrong in your model, doing multiple iterations, and trying to overfit your model, looking at which all scenarios it is missing. Because what will happen is, if you open your test envelope more than once, then it is no longer a test data set. It will become your delayed training data set. Now, in practice, you should always ask 3 questions to every decision that you make. First question is going to be that, did this decision use any of your test set information? Second question you should ask is, did this decision assume any of future knowledge? And the third question you should ask is, did it use any signal from your outcome variable which will not be available at the time of inference? If your answer to any of these questions is yes, what that means is your information boundary is broken. Your evaluation metric will be lying to you, and your model will fail silently. Every ML abstraction exists because a system has a failure mode. The train test split exists to enforce one guarantee in the system. That is, the future stays invisible to every training decision that is made. In next video, we will be discussing about leakage, how it happens in real pipelines, and how to catch it before it goes into production.